Welcome back to Miss Lisa's Math and Science YouTube channel. And today we're talking about chemistry. Like, share, subscribe. My goal is to get 1,000 subscribers so that I don't have to record and then upload it. It takes forever. It's so irritating. But anyway, positive thoughts. Maybe I'll get it. I think I'm at like about 270 now. So I'm over a quarter of the way there. So maybe it's possible. So this is chemistry is a class primarily designed for homeschoolers, but if you like the way I explain things, come on in. Today we are going to be talking about chapter 5 in that book. And we're going to be talking about chemical names and formulas and the periodic table and a lot of things like that. But before we do, we have a few other things we need to discuss. Really, it's a monologue, but you know. I was going to tell you that there are 26 chapters in this book, and we are not going to do them all. And I've been going at about a chapter a week. A regular school year has 40 weeks. Normally when I do this class with homeschoolers, we do 38 weeks. So you can see there are a lot more weeks than there are going to be chapters. So I've been doing a chapter a week, but if that's too fast for you, you can slow down. Or if it's not too fast for you, you can keep going and you can get through with your chemistry in faster than a school year. So just to let you know that we will skip some chapters. Some things are a little too detailed, and that we're going at a real fast pace. So if this pace is too fast for you, you work at your own pace. Especially you might want to go a little slower and take more time with the labs and activities and really enjoy it more. And also, they pack a whole lot into these chapters, so you might want to supplement and go find some more videos about these topics to understand them better also, because I'm going pretty quick. So if that pace doesn't work for you, you are welcome to slow it down, and also to find supplementary stuff. I won't even know. You don't even have to tell me. I won't know. All right, so what we're talking about today is chapter 5, chemical names and formulas. So we've been learning about chemistry, and now we're getting really down to where we'll be able to do things, because we're going to learn more about the language of chemistry with the names and formulas. Now, where are all the elements found? And I'm turning in the book. It should be in the back of your book. If you turn to the back of your book, you find the list of all the elements. It's on the periodic table. So I've got my periodic table here. I'm going to turn it so you can see the periodic table. All right, now the elements are arranged in an order of increasing atomic mass. And they're arranged, I could get another periodic to show you, but they're arranged both in families or columns, or they're sometimes called groups going up and down, and periods going vertically. So the ones that are alike are the ones in the vertical columns, the groups or the families. And they are more alike than the ones in the periods. But normally, when I teach this during the school year, I've got this book I read from Sesame Street. And it talks about the people in my family. It's people and monsters. And I always make the point to the kids that the families are more alike, even though they have similar members. They both have a dad, they both have a mom, they both have kids. Even though they have similar members, that they're more like their family than they are like their representative members. So on the periodic table, these columns are the ones that are a lot alike. For example, there's a column called the noble gases, and they're all very unreactive, and they're gases at room temperature. The one next to it is called the halogens, and they make salts. And they disinfect. They're all disinfecting. So they have certain properties alike. So these families are alike, and even though they have similar members, they're more like each other. Okay. So we talked about that. Also, on the periodic table, if it's like this, there's a stair step going across right here. Everything from the stair step over this way are metals. Everything from the stair step up over here are non-metals. So you will read more about those characteristics. The ones, I really need a periodic table to show you. I should have got one out. I got this one. Okay, so these are the metals, those are the non-metals, These metals right here in this rectangle are called transition metals. Okay, they have a special name. They have some certain properties. And then these other nonmetals right here in the triangle, sometimes they're called basic metals. Your book calls them other metals, other, I think, what did I just call it? Inner transition metals. I don't know of any other book that calls them that. Sometimes, but usually they're called other metals. And then non-metals are not metals. The ones at the stair step, the border between the two are metalloids, and that's where like silicon is. It has properties of metals and non-metals. Metals are conductors of heat and electricity. Non-metals are not. Metalloids, there on that stair step, are semiconductors. So they're kind of halfway. And they used to not be as important, but now they're used in the computer industry, so they're very important. All right, so you're going to read about those. Now, in the atom, you have the nucleus. In the nucleus are protons and neutrons. Around the outside are electrons. The protons are positive, the neutrons are neutral, the electrons are negative. If an atom has the same number of electrons and protons, it's neutral, it's balanced. The negative and the positive neutralize each other out. If you have more electrons, it's negative. If it has more protons, it's positive. And then it's got a special name. If it's a charged atom, it's called an ion, And if it is a positively charged ion, it's a cation. So I always tell the kids at school that cats are wonderful, furry, positive creatures. So we're going to remember that cations are positive. And on the negative ions are called anions. And fire ants are negative creatures. Now, there are students who disagree about cats being positive, but we can all agree that fire ants here in Georgia are negative. And I was teaching this last week in a chemistry class I teach in public school. And I had some people going, no, cats are not positive. And I said, but tell me, have we all been bit by a fire ant in here? And every single person, including me, raised my hand. And we all agreed fire ants are negative. So anions is not antions, but it sounds kind of like it. And that'll help you remember. Anions are negative. Now, how do they become positive or negative? Well, it's not the nucleus. The nucleus, where the protons are, always stays the same. It's the electrons that are on the outside, and they can get rubbed off, making it where there are less electrons and more protons, and it's positive, it's a cation, or it could grab some from someone else, they could be rubbed on, and then that would give it more negative, and it would be an anion. On the periodic table, these over here lose their electrons and become cations. These over here gain electrons and become anions. And you're going to read more about that in your chapter. Okay. I think we covered all of that. Yep. Okay. Now we've talked about atoms, and you know this already. They get together and form compounds. You know about H2O, hydrogen and oxygen getting together to be water. You know about NaCl, sodium chloride getting together to be salt. These are compounds, and they can be formed two ways. One, they can transfer electrons from one to the other, and then one becomes positive, one is negative, and what do opposites do? They attract. So then they stick together. That is called an ionic bond. When you have a positive and negative and they stick together because opposites attract. And that's salt. That's what sodium chloride does. The other thing they can do is they can share electrons. When they do, that shared electron is called a covalent bond, and that's what sticks them together, is the fact that they're sharing electrons. Ionic bonds are more, you can think of them more like salt, more brittle. Covalent bonds are more squishy. Guess what your flesh is? It's covalent bonds, because you are a carbon-based life form, and carbon tends to make covalent bonds. All right, so we talked about that, making sure I hit everything. Oh, in the ionic bonds, it's not really one sodium attracted to one chloride. Instead, it's they will put themselves into a pattern. It's called a crystal lattice. So it'll be sodium chloride, and then like underneath the sodium will be a chloride. There'll be one on each side. Around this chloride is sodiums on each side, and it makes crystals. So ionic bonds make crystals, and you will see that in your book on page 112. All right. Now, the formula is what I've been saying. Water is H2O, sugar, C6H12O6. They do ethane, C2H6. But you're familiar with that. You already know about H2O. Okay? Now, with salts, I already told you, it's not really one sodium and one chloride. But if you reduce it to just the most simple thing, that's what we write. So we just write NaCl for the formula for salt, sodium chloride. And that's called a formula unit. Okay, we're good. We learned all of that. Now, the law of definite proportions is this. That the subscripts, like an H2O, they're always whole numbers and they're always the same. Water is always H2O. It's not H2.5 O or something like that. It's always the same. And it's because they reflect the ratio of atoms. Water is H2O, meaning it has 2 hydrogens and 1 oxygen. We can't have half an oxygen or a quarter of a hydrogen because that would be splitting the atom. And what happens when you split the atom? That's right, it explodes. That's how you get bombs, is from splitting the atoms. I always think of Plankton going, hydrogen bombs. Oh, no, uranium bombs. That's the one he does in the friendship song. F is for friends, that something together. Some of y'all know what I'm talking about. All right, so the law of definite proportions reflects that these atoms combine and you don't split the atoms. All right. There's some math in here. You can look at the sample problems. Now then, let's talk about what these atoms like, what the atoms want to do on the periodic table. Here's my periodic table. This family down here is called the noble gas. They have filled orbitals, which means that they're happy, that their energy makes them happy. So just like how maybe people in England all want to be like William and Kate and their children, the noble family, all the elements want to be like the noble gases and have filled orbitals. So how they do that is by transferring electrons or by sharing electrons. These guys over here have one too many to feel like a noble gas, so they want to lose 1 electron. When they do, they get a charge of +1. The ones next to them want to lose 2 electrons. And when they do, if they lose 2 negatives, they end up with the charge of +2. These over here want to lose 3 electrons. The carbon family sort of does different things, so we kind of skip that one. Over here, this first column next to the noble gases wants to gain 1 electron, so they want to be -1. The next family, the oxygen family, wants to gain 2, and the family next to that, nitrogen's family, wants to gain 3. All right, and when they do, they become +1, +2, +3. All right, I think you got that. And then that's how they work out their opposites attract. All right, next idea. And so that's in your book on page 119. Okay, now in the middle, where those transition metals were, some of them, especially the ones that you really think of metals, copper, iron, mercury, lead, tin, chrome, manganese, cobalt, a lot of those can have different charged states. So it is called ionic charges, and they're in your book in a list on page 120. When they have more than one state, it is reflected by a Roman numeral in the middle. Look at that chart. If you have to pause it right now, pause it and take a look. But you can see, like, if copper has a charge of +1, it's called the copper 1 ion. If it has a charge of +2, meaning it lost 2 electrons, it's the copper 2 electron. They used to have an old name for these. They were more Latin. So copper was cuprous or cupric. Iron was ferrous or ferric. So sometimes you still see those old names. Sorry, need just a little bit of water. I've talked too much today. This is like my 1, 2, 3, 4, 5, 6, 7. This is my 8th video today. All right. So polyatomic ions. Turning your book to page 122. There are some groups of atoms that act together like an ion. One is oxygen and hydrogen. They can act together and get a charge of -1, and they're the hydroxide ion. So these are called poly means many, polyatomic ions. They're little clusters of atoms that act together like one thing with one charge. And they're found in your book in a chart on page 123. Now, if you bought your book from me, then probably somebody already wrote that this chart on your periodic table is on page 123, because you end up referring to it a lot. So it's a very important one. Another important one is the metal activity series on 191. And there's a big colored periodic table that shows you all the different areas of it on page 354. So be sure to look at those also. All right, so that's talking about the polyatomic ions. Now, how do you name these things? Now, a lot of things have common names like water, but then they also have their like salt, but they have their scientific name, like sodium chloride. A binary compound is made out of 2 different kinds of atoms. And when you have it, you do the cation first, the anion second. And if it is ionic, then you change the ending of it to "ide." So like potassium chloride in your book on page 125 is KCl. So it's made out of potassium and chlorine, but we don't call it potassium chlorine, we call it potassium chloride. It's not sodium chlorine, it's sodium chloride. The "ide" ending lets you know that it is ionic. It's made out of 2 things. You always write the cation first and then the anion. Now, what about the subscripts? Let's see if I can write this on the board behind me. Oh, an extreme close-up. Doodle-doo. I'm going to get rid of this right here. All right. Y'all know I'm Miss Lisa. All right, so if you have iron, you've got iron with a +3 charge. And you have oxygen with a -2 charge. When they get together, the charges must balance out. And if they got together just FeO, it wouldn't be balanced because 3 minus 2 is 1. So what you do is you crisscross the charges. Crisscross applesauce, like this. You write Fe2O3. You write them down on the bottom you give the 2 to the iron and the 3 to the oxygen, and you write it with no charge. And that makes it all work out. You can see it in your book. All right. Let's see. I think y'all can read that. Y'all can read that. That's all pretty much the same thing. All right. Now, things are covalent. Covalent compounds are named by a different system. And we are not going to go into all of it until later when we learn about organic. We're going to do a chapter on organic. But this is where we use the prefixes. Look in your book on page 131. Here you see the prefixes. Mono is 1, di is 2, tri is 3, tetra is 4. You don't use these with ionic, only covalent. So look at example 9 on page 131. You have N2O. How you name that is dinitrogen, because you have 2 of them, and you have one oxygen, so it's monoxide, dinitrogen monoxide. So you use these prefixes to tell how many for the name. You can read through it in your book. It's pretty easy. Now, acids, there are some rules for it, but there is a list of some common acids on page 133. And what I want you to do is just memorize them. There are some, I might make another video to show you too on how to do it. Or I might put, for those of you who are on the Facebook group, there is another video. There's a series of videos where a guy goes through it on YouTube and does a real good job of showing how to name each thing. It's a little more detailed, and I might post those on the Facebook group so you can go watch it. His name is Mark Peterson. It's Peterson Science. He's got some good videos too, ones you might want to add with watching mine if you don't understand something. All right, so we got that, and that is it. All right, that's our chapter. Like, share, subscribe. Science is great.